Hello, dear children, dear students. Today we have Proposition 4 of Book 2. Proposition 4 of Book 2 states, if there be a line and it be cut at random, the square on the whole of that line will be equal to both the squares on the two segments added together plus twice the rectangle contained by the segments. Okay? Now remember, we want to review something. If you have a line, you can only get one size of square on that, okay? So if this line equals that line and it's a square, this square is the square on that line. If this line equals this line, and these are all right angles and equal made a square, then this square is the square on that line, okay? A square is defined by a line and right angles. Likewise, a parallelogram. A parallelogram is defined by two lines and a right angle. These two lines plus a right angle make this parallelogram. They don't make that parallelogram. Okay, so any parallelogram that's drawn with these sides and a right angle is the parallelogram, sorry, the rectangle, because it's a right angle, parallelogram, rectangle parallelogram. If it's a rectangle, if it's a right angle, it's a rectangle, and it's going to be defined by these two lines and that right angle. That's it, okay? So here's what we're going to prove. We're going to prove that if a line be cut at random, the square on the whole line will be equal to the square on the two segments added together and the rectangle, or twice the rectangle, contained by those two segments, okay? So let this be that very line cut, and I made it red and blue to make it easier for the imagination, okay? Thus it is required to show that the square on this line is equal to the square on this line, plus the square on this line, plus twice the rectangle contained by this line and this line, okay? So let's make ourselves a square. We know we can do that from, what was it, Proposition 6, I don't know, 46 maybe, 46 of Book 2. Okay, so do the best we can making ourselves a square. Now look how I'm making the drawing as I do the proposition. It's always better, because it's too easy just to already have the drawing done. I know you guys are trying to be efficient, but it's also a little bit of a trick to make your life easier. We don't want to have life be too easy when it comes to Euclid. It's going to be más o menos a square. Okay? Sorry, I did that wrong. I want to square on the whole of the line, so let's not do that yet. See? That's why I like to have you draw. I didn't do that on purpose, but I'm glad I made that mistake, so you guys realize, so I can realize whether you're thinking as you're doing it. Okay, so let's make this big old square. We're going to do this in different colors because we're eventually going to use those colors. Say something like that. It's probably going to be a little bit too big. So for me to go, okay. And then we'll do this. Have this be the complement. And then this is going to be our other little square, so you'll see. Okay? And have this be here. And have this green be here. Okay, so this is a square on this line. These are right angles. These are right angles. This is the line. We drew this, cut it equal to this. We drew this parallel to this, cut it just like we do in Proposition 46, and we made ourselves a square. We know we can do that. Let that be the square on this line, okay? Now, pay attention as we make the figure. It's important how you make the figure, because what we want to do is end up getting a square on this line and a square on this line, and then two rectangles made up by this line and this line. It's a really cool problem. Let's connect these 2 points. Okay? Let's, from this point, draw a line parallel to this line. Okay, I'm going to do that with different colors again because this is going to end up being, okay, now with green. Okay, now this is important right here. From this point of intersection, you can't just say, let's draw a line parallel to this, because you don't know if it's going to cross this. You can't just go, okay, because you don't know if it's going to cut this. You want it to cut it. So just from this point, draw a line parallel to this line. Okay? And then draw it through until it reaches it. Draw it through, continue the line. Okay? Great. Great. So now, we need to prove, in the process, we need to prove that this is a square and this is a square. We made this a square. We need to prove that this is a square and this is a square. So let's start off by proving that this is a square, okay? And by the way, let me color it in just so you can make it easy for yourself. Okay? And I'll color this one in to make it easy. And then I'm going to color, these will be the complements, right? If everything we did was correct. Great. So, let's see that this is a square. Now we know that this is a square. We drew it such. Okay? So this side is equal to this side. Look at this triangle here. We have this side equal to this side in this triangle. That is to say, it's an isosceles triangle. Therefore, the angles at the base are equal. So, this red angle is equal to this blue angle. Okay? But this red angle is also equal to this angle. Why? Because you have two parallel lines and a straight line falling upon them. Therefore, it creates the exterior angle equal to the opposite and interior angle. Okay, so let's use green here. So we use brown. So this angle, brown angle, is equal to the red angle. But look, this blue angle is also equal to the red angle. Two things equal to the same thing are equal to each other. So this is equal to this. Well, we also know that at any triangle, see this triangle? That if the angles at the base are equal, then that's an isosceles triangle. So this is equal to this. Great. But this is a parallelogram because we drew all these lines parallelogram, and we know that opposite sides of parallelograms are equal. So this is equal to this, and this is equal to this. So if this equals this and this equals this, they're equal to each other. So this four sides are going to be equal, or are equal. Therefore, we got a figure with four sides equal. If we can show that it's right angled, then it's going to be a square. Now, we know that we have two straight lines that are a straight line falling upon two straight lines, and it creates interior angles equal to two right angles. Let's do this one in black maybe. But that was drawn, so these two added together are equal to right angles because you have parallel lines, and with a straight line falling upon them, it creates the interior angles equal to two right angles. Remember, we proved that. But this is a right angle. If this plus this equal two right angles, and this is a right angle, this is a right angle. And then opposite sides, opposite angles of parallelograms are equal. This is a parallelogram, we drew it as such. So this is equal to this. And this, therefore, is right, and that's right. Therefore, we've got a figure whose sides are equal, and a four-sided figure whose sides are equal and at right angles. Therefore, this is a square, okay? And it's on this line. So we've got a couple things going on here. We drew the square on this line. Now we've got the square on this line. Good, we've done that. Look, for the same reason, we can show that this is a square. By doing that same trick, you can do it that this, these are right, blah, blah, blah. You show it the same way. Okay, just you can do that if you want. I'm going to make the video short. You should do that the same way. So this is a four-sided, this is equal four-sided, and the angles are right, therefore it's a square. Now remember what we said. If you have a square and it's one of the lines are equal to that given line, you can say that this is a square on this line. So because this is equal to this, because this is a parallelogram, okay, this is equal to this, and this here is the square on this, and this equals this, you say this also is a square on this, okay? Because, again, once you've got that equal line, and it's defined, you've got that line, you got a right angle, this is the square on this. This, because this is equal to this, is the square on this, because these are right angles. Great. So now we've got our square on this, we've got our square on this, and we've got our square on this. Okay? Great. Now let's look at these two figures. Remember, this is a big parallelogram. We know that complements of a parallelogram are equal. Okay? So this green parallelogram is equal to this green parallelogram. Okay? But look at this parallelogram. It's made up of this and this. Why? Well, it's clearly made up of that because that's one of the sides. And because this is a square, this is equal to this. So, if this is made up of this, and this is equal to this is made up of this, and this, being that they're all right angles. Remember, we drew this at right angles, two parallel lines. These two are going to be equal to two right angles, and that is a right angle, therefore that's a right angle. Opposite sides are right angles. Okay, so this is a rectangle. It's not just a parallelogram now, it's a very specific parallelogram called a rectangle. That is to say the angles are right. Okay, so this is the rectangle contained by this and this. And this is equal to this, which is to say that twice this is equal to this plus this. Okay? Now, look at this. This plus this plus this plus this are equal to this. The big chunk is equal to its parts. Okay? Big chunk equal to the little chunks. Okay? But we showed that this chunk is the square on this line, and this chunk is the square on this line. And this chunk and this chunk are twice the rectangle contained by this line and this line. Therefore, if this big chunk is equal to this chunk plus this chunk, and this chunk plus this chunk plus this chunk plus this chunk are equal to this big old chunk, I'm going to do that again. If this big chunk is equal to this chunk plus this chunk plus this chunk plus this chunk, and this big old chunk is the square on this line, and this chunk is the square on this line, and this chunk is the square on this line, and these two chunks are the rectangle contained by this line and this line, then it must be the case, as the big chunk is equal to little chunks, the big line is equal to the square, the square on the big line is equal to the square on one of the segments plus the square on the other segment, plus twice the rectangle contained by the two segments. Okay? I could have done that better, more clearly, but I'm really trying to make sure you guys see it, okay? Remember, it's about the line, and you make your drawings. You have to be careful how you make your drawings, and then you show when you made your drawings that you got the figures you wanted, two squares plus two rectangles that are equal to each other, okay? Therefore, we have shown that if there be a line and you cut it at random, excuse me, if there be a line and you cut it at random, the square on the whole line will be equal to the whole sum of the squares on each of the two segments plus twice the rectangle contained by those two segments. Quod erat demonstrandum. We made something in order to see that it's true about it. It's the very nature of the line. It's in the very nature of this line. But if you cut it at random, that will happen. That the whole square on that line, the square on that whole line will be equal to the squares on the segments plus twice the rectangle contained by the segments. Thank you. Bye.